Hello friends, this video is brought to you by www.moeteaching.com.
In this chapter of Heron's formula, we will study how to find the area of a triangle whose sides are given by Heron's formula. Then we shall take up some examples to depict that area of quadrilateral can also be calculated using Heron's formula. We have studied in our previous classes how to calculate perimeter and area of some of the figures like square, rectangle, triangle, and some other quadrilaterals like trapezium, parallelogram, etc. Let us also recall that unit for measurement for length or breadth is taken as meters or centimeters, while unit for measurement of area of any plane figure is taken as meter square or centimeter square. Let us recall that area of a triangle is given by 1 by 2 into base into height. When the triangle is a right angled triangle, we can directly apply the formula by considering one of the sides as base and the other one as height, and then the area will be half into base into height. So we get the area as 30 centimeters square. Note here that we can interchange height and base. That means we can consider AB as the base while BC as the height. Now suppose we want to find the area of an equilateral triangle whose each side is 10 centimeters long. To find the area, we need height. So to find the height, what we can do is mark the midpoint of line QR as M and join PM. Now by using Pythagoras theorem for the triangle PQM, we can find the height of the triangle PQR. So let us try to find the height. By Pythagoras theorem, PQ square should be equal to PM square plus QM square. So let us substitute the values. 10 square is equal to PM square plus 5 square. On solving further, we get PM square is equal to 75 centimeters, which gives PM equal to under root of 75 centimeters, which is equal to 5 root 3 centimeters. So now we have height of our equilateral triangle, and the area can be calculated by substituting the height in half into base into height. Note here, we are taking M as the midpoint of side QR and joining it with P and saying that PM is perpendicular to QR, remember that this is possible for equilateral triangles. Let us see what happens if we have an isosceles triangle. We have two sides equal while the third side is not equal to them. Then let us draw a perpendicular on line YZ which passes through X. Then again for isosceles triangle, the perpendicular will bisect the other side. That means again we have a right triangle which can give us the height of this isosceles triangle. Let us mark the point as P. Again, using the Pythagoras theorem, we will have xy whole square should be equal to yp whole square plus xp whole square. Let us substitute the values. 5 square is equal to 4 square plus xp square. This will give us xp whole square equal to 25 minus 16, that is 9. So xp equal to under root of 9, that is equal to 3 centimeters. So we have the height of the isosceles triangle, and now we can calculate the area. Half into base into height will give us the area of the isosceles triangle. Now suppose we have a scalene triangle. Although we know the length of the sides of this triangle, but to find the area we would need the height, about which we have no clue how to calculate. So, in such cases where it is not possible to find the height of the triangle easily, we can use HERON'S formula, which we shall learn in the next slide. Let us now understand the HERO'S formula for finding the area of the triangle whose height cannot be calculated easily. Consider a triangle ABC, the length of whose sides is small a, small b and small c. Then we know that perimeter of ABC, triangle ABC, will be A plus B plus C. So we calculate S, which is called semi-perimeter, which is equal to A plus B plus C whole divided by 2. In other words, semi-perimeter is half of perimeter. Once we calculate semi-perimeter, then the area of the triangle is given by under root of S into S minus A into S minus B into S minus C, where A, B and C are the lengths of the sides of the required triangle. It is important to note that Hero's formula can be applied to any type of triangle, be it equilateral triangle, isosceles triangle, right angled triangle, or a scalene triangle, provided we know the length of the three sides of that particular triangle. Let us take up an example and learn to apply the Hero's formula. Consider the triangle on the screen. Here we have A equal to 40 centimeters, B is 24 centimeters, and C is 32 centimeters. Let us first calculate S, that is the semi-perimeter, which is half of the perimeter, that is 40 plus 24 plus 32. This comes out to be 48 centimeters. Now by Hero's formula, area is equal to under root of S into S minus A, S minus B, S minus C. So let us calculate S minus B, which will be 48 minus 24, that is 24 centimeters. S minus A equal to 48 minus 40, which is 8 centimeters. S minus C is 48 minus 32, which is equal to 16 centimeters. It now remains to substitute these values in the formula. So let us do. S is 48, S minus A is 8, S minus B is 24 centimeters, and S minus C is 16 centimeters. After calculations, we find the value as 384 centimeters square. So we have seen how to apply Hero's formula and calculate the area of any triangle. Now let us take up some more examples